Okay, so one comment I want to make before we go any further is I want to address something that might have popped into your head by now. And you might not be used to seeing lines written in this fashion. And it's certainly not the case that this is the only way to write a line. There's other ways to write a line, and those might be ways that you're more familiar with. Let me just remind you of another way you can write a line. What if I gave you the following example? If I wrote down, I'm going to write it over here, so I'm going to use this copy of the Cartesian plane to write an equation and draw a graph. What if I gave you the line y equals negative 3/2 times x plus 3? Well, you might recognize the form that this line appears in. This is called slope-intercept form. So you've got y equals some number. A lot of times you'll write this as m, the slope, times x plus some other number over here, which you will refer to as the y-intercept. Okay, so that's really how you should interpret lines written in that form. And what do those things mean? What is the y-intercept? Well, the y-intercept is the place that the line crosses the y-axis. So let me just label a 3 right there on the y-axis, and that will be a point on our line. And remember what the slope means. It tells you the orientation of the line. And the idea is that a line is completely determined by its orientation, or the slope, and at least one point that you already know the line goes through, which in this case, the y-intercept works perfectly because we already know the line goes through the y-axis at the point 3. So if we know its orientation, remember how this fraction gives you the slope of the line? You've got rise over run. The slope, let me just jot that down here, slope is equal to rise over run. And rise is the change in the y-coordinates, and run is the change in the x-coordinates. So the rise is -3, so we're going to go down 3 units from positive 3 on the y-axis. That's going to take us down to the origin. If I go up from up here and I go down 3, that'll take me here. And then now I'm going to go 2 units to the right. So if I move 2 units to the right, that'll put me right here. On the x-axis, that'll put a 2 there. And now I can go down 3 over 2, and that's another point on the line. And once you have 2 points on the line, you have the entire line completely determined. You just connect those 2 points with a line, do it as straight as you can. Doesn't have to be perfect, but you do your best. And now you've got yourself an example of a line. So this equation really generates that line. And you might say, well, this doesn't really look exactly like this form, but you could certainly take this line and you could write it in this form. Right? There's nothing wrong with doing that. How would I do that? Well, I could start with y equals -3/2 x plus 3. I'm just going to make another copy of the line. I could start by multiplying the entire equation by 2. Like multiply the left and the right hand sides both by 2. And what I would get is 2y is equal to -3x plus 6. Right, and then now what? Well, I could add 3x to both sides, and I'd end up with 3x plus 2y is equal to 6. And these two equations, this one here and this one here, these are equivalent, right? They're the same. They're different ways of writing the same relationship. That you could say they're different equations, but they really represent the same line. So I just wanted to make that point. Let me draw a line here just to separate this. I don't want those two ideas to get blended together. But if you have a line in this form, you can always write it in this form just by doing this. Right? So that's available to you. Okay, so in this case, your constant term would be 6. Your coefficient of x would be 3, and the coefficient of y would be 2. Okay, so you can always do that. Even if the line isn't already written in that form, you can always rewrite it so that it is. Okay, so this is actually an example of a more general idea called a linear equation. Now everything I've seen so far is an example of a linear equation in 2 variables, but we can generalize this to any number of variables. That's the first real idea that we're going to talk about in this course. This generalizes to more variables. So This is a definition. So this is how I'll write definition in this course. Just I write DEF, just short for definition, and then I write an N with 2 lines underneath it. Just that means definition. It's just a shorter way to write it. Okay, so what are we going to talk about? Well, like I said, the idea is you can generalize the idea of a linear equation in 2 variables, and you can just replace that 2 with any positive counting number. And then you can talk about a linear equation in 3 variables, or a linear equation in 6 variables, or a linear equation. If you really wanted to be crazy, you could say a linear equation in 342 variables. There's nothing stopping you from doing that. That's the idea that we're going to try to generalize to now. So let's start with saying, okay, well, let n be some counting number that's greater than or equal to 1. So really what the role that this n is going to play is it's going to be the number of variables in our equation. But we want to stay general as possible, so we're just going to leave that as an unknown number. But that's just some fixed number in the background that tells us how many variables we have. So with that in mind, now we can say the following. A linear equation, we can say what that is. A linear equation in, well, really, we're talking about n variables here, because that's what n does. It tells us how many variables we have. So pause for a moment. If n were equal to 2, we could do exactly what we did up here. We could just use the letters x and y for the variables. Well, what if n was 3? Well, then we could use x, y, and z. That would be a perfectly suitable choice. And what if n was 4? Well, then you'd need a 4th letter for a variable. And you might use w, the letter that comes right before x. But if you start talking about 5 variables, 6 variables, what if you talk about 60 variables? You're not going to be able to use a different letter for every single variable. You're going to have to, well, you could use different symbols if you want, but things might get difficult to keep track of. So when you start to get more and more variables, rather than using a different letter for each one, which technically is allowed, if you want to do that you can, but it's not advisable. Typically what you'll want to do is just use one letter for the variables, but then give them an index so that you can specify which variable you're talking about. So here's what I'll do here. I'll say a linear equation in the variables, and here are our variables, x1, x2, and I'll just keep on going until I get to the very last variable, xn. So see, what I'm doing is I'm just using the letter x for all of my variables. And then I'm just using the subscript. So 1 here as a subscript, that just means talk about your first variable. The 2 as a subscript means talk about your second variable. And then the next one would be x3. Well, that'll be the third variable, and so on. All the way until I get to n. And remember, n was the number of variables we had. That's what this means. So let's actually just say that, number of variables, as a reminder of what this is for. Okay, so, well, that's a lot of talk, and I really still haven't told you what exactly a linear equation in these variables is yet, and that's what we're going to do now. So a linear equation in the variables x1 up to xn is just one of the following form. So it's an equation of the form, and here's what it would look like. I'm going to go a1 x1 plus a2 x2, and so on, all the way up to my very last variable, which is also going to be multiplied by an. So an xn, and that is going to equal b. And this is true for some values, real numbers, a1, a2, all the way up to an, and then also b in the reals. So I'm going to go through these symbols now and just make sure it's clear what we're talking about. So let's look up here. What has changed from this equation back to the last example we saw, where we had our linear equation in 2 variables? Well, we had our variables x and y, and each of them was multiplied by a coefficient, which was a constant. And then we had a constant term over here on the right-hand side all by itself. Compare that to here. what's happening over here? Well, the variables, now there's lots of them, x1, x2, and I've used dot, dot, dot to indicate that it just keeps on going because I don't really know how many I have. I'm trying to stay general. There's n in total. I don't know how many variables there are exactly. But each one of those variables has a multiplier. It's multiplied by a coefficient. So a1 is just the symbol I'm using to represent the coefficient of x1, the variable. a2 is the coefficient of the variable x2, and so on, right? You can see it's easy to keep track of because I'm using the same index for the coefficient as I am for the variable. And I'm using one letter for all my coefficients. I'm using A for all the coefficients, and I'm using X for all the variables. And then I just use one different letter, B, for the constant term. So each one of the variables has a coefficient, and down here this just quantifies that. So it just says a linear equation in the variables x1 through xn is just something in this form where, by the way, a1, a2, all the way up to an, as well as the number b, they're just real numbers. This symbol here that you see, this just means belongs to. So this just means a1, a2, up to an and b, they all belong to the real numbers. So just basically quantifying, saying, by the way, this is just a number. I'm not going to specify what it is at this stage, but it's just a real number. So that's the definition of a linear equation.